On behalf of the Lawton Standard family, welcome to 4-Minute Metallurgy, where we will attempt to explain metallurgical or foundry engineering concepts in 4 minutes or less. I'm Blake Allbritton. Episode 1, what is ductile iron? Ductile iron first emerged in the 1940s as an advancement in iron casting technology that provided improved strength, fatigue resistance, impact resistance, and of course ductility over previously available iron castings. But what is it? At the microstructural level, ductile iron is a solid solution of iron, carbon, and silicon in the form of ferrite, pearlite, and graphite nodules. What is ferrite? Ferrite simply is iron. Ferrite, as solidified in ductile iron castings, is a soft, low-strength phase that appears in halos around graphite nodules in 2 dimensions, or in 3 dimensions, encapsulates the graphite nodules. What about pearlite? Pearlite is a mixture of ferrite and cementite, or iron carbide, that forms during solidification in a process driven by localized carbon concentration and diffusion as solidification occurs. To learn more about how and why pearlite forms, check out the other series, 40-Minute Metallurgy. For 4-minute metallurgy purposes, pearlite is a hard, high-strength phase, controllable by alloy addition, and that can respond to heat treatment. Graphite is carbon that is rejected from solution and forced to solidify in the form of soft spheroidal nodules. So what is ductile iron? Relative to prior iron casting alloys, ductile iron is capable of higher strength, greater elongation, greater impact resistance, greater fatigue resistance, and better strength-to-weight ratio. It changed the game. This graphic is a differentially etched transverse section of a tensile specimen showing the morphology at the fracture surface. The arrows point to places where the matrix of ferrite and pearlite ripped around the graphite nodules. No nodules were ruptured or transected. This is one of the mechanisms by which the microstructure of the material controls its mechanical properties. Commercially in the U.S., most ductile irons are specified by ASTM A536 and sold by grade names containing the 3 main identifying characteristics: tensile strength, yield strength, and elongation. The lower the strength, the higher the elongation, and the higher the strength, the lower the elongation. 60-40-18 really just says 60,000 psi tensile, 40,000 psi yield, 18% elongation, minimum required. The image here is pretty self-explanatory. These 5 grades are not exhaustive. There are many other grades of ductile iron, but these 5 grades are generally available as cast without requiring heat treatment to achieve required mechanical properties. Back to microstructure. At the low end, 60-40-18 is going to have mostly ferrite with maybe a little bit of pearlite around graphite nodules, and the 120-90-02 will likely have 0 ferrite with an all-pearlite matrix around the graphite nodules. How is it made? Carefully sourced raw materials are weighed by grade and charged into a coreless induction furnace where a high-frequency magnetic current is introduced, exciting and vibrating atoms within individual pieces of charged material, which creates enough heat to cause the materials to desolidify. The current in the high-frequency magnetic field introduces a strong stirring action and helps to homogenize the melt bath. This melted iron is called base iron. The nonmetallic impurities float to the surface and are skimmed off. The base iron is then poured into a ladle containing magnesium. The reaction with magnesium is what causes graphite to solidify in spheroids instead of rosettes or flakes. The reaction is highly energetic. Once treated, the iron, which is now ductile iron, is poured into sand molds made from highly engineered patterns based on customer models or drawings. These ductile iron castings are clean and ready to ship for use or for final machining. From a few pounds to tens of thousands of pounds, we can do it all. What can we cast for you?